So this one, it says pipe A can fill the tank in 6 hours, pipe B can fill it in 2 hours less than it takes drain pipe C to empty the tank. With all three pipes open, it takes 3 hours and 20 minutes to fill the tank. How long would it take C to empty the tank, right? That's the question, right? Right? So first, let's deal with this because we're going to deal with it at some point. Okay. We're going to deal with it at one point, and so I have this 3 hours and 20 minutes. It all needs to be in terms of hours, right? So when you see 3 hours and 20 minutes, that's 3 hours, and then I've got to figure out what fraction of an hour that is, so that's 20 over 60. So this is 3 1/3, which gives us 10 over 3. Is everybody okay with that? Right? So 3 hours and 20 minutes is 10/3 of an hour, right? It's that many hours. So we're going to have to use this number instead of the 3 hours and 20 minutes, all right? Yes?
Is it 4 over 3?
Yeah, because you wrote 4 over 3 yesterday.
Oh, yeah. Yeah, I think it is 4 over.
For this problem?
Yeah.
Well, I messed up. It's 10 over 3. Like, this times this plus this, isn't it? Not 10 over 3?
Yeah.
I did one problem that was 4 over 3, but okay. Okay, but all right, but this is definitely 10 over 3.
Yes.
All right, so we're going to need that in a little bit. So, what are the biggest differences between this problem and like problem 3 that we did? How many pipes do we have?
3.
So we have 3 things. So what we really have now is we've got the rate of pipe A, we've got the rate of pipe B, we have the rate of pipe C, and we have the rate of them working all together, right? And given this, what do we know? So what's going to be here?
1 over 6.
1 over 6. Everybody okay with that part? So this has got to be 1 over 6 because what goes here is what it did divided by how long it took to do it. What else do we know?
The total.
The total, right?
10/3.
Remember we had this as 10/3, right? And so we know this is going to be 1 over 10/3, right?
1 3/10, right?
What?
1 3/10, right?
Yeah. Are we okay with that?
Yeah.
And so what's a little more confusing is like these things, right? And they're related to each other because, I mean, that's what they say in the problem. It says B can fill it 2 hours less than drain pipe C, right? So those are related, right? And anytime they have things that are related, there's going to be an X involved, right? And so now the question is, what do you let equal X?
C.
And it's whatever you're looking for, right? And so this is asking how long would it take C to empty the tank. And so that's going to give me 1. That's what we're going to let equal X. Right? And now let's talk about this thing. Well, if this, and so this will be 1 over something, if this is the time it takes C to do its thing, how do we determine the time it takes B to do its thing? X minus 2, because B can fill it 2 hours less, so we end up with X minus 2, right? Is that easier the second time through? Right? Of course, now we need our equation. I know this is together, right? And because it's together, right, that we have to combine these. And this one's a little more involved because A and B are adding and C is taking away. And since A and B are adding, I'm going to add these together and take away this, and now I have my equation. And did I get a chance to talk about that 1 over this is the same thing as 1 over a fraction means you flip the fraction?
Yes.
So if I flip the fraction, that's going to give me 3 over 10. And now we have our equation, right? All right. Do I make you solve this? We have time? Yeah, we have time. All right. Solve. All right. So so that we have enough time to actually talk about some of the other types of problems, I want to go ahead and do this one. All right. So I don't like fractions, right? And if I don't like fractions, I got to figure out what can I multiply that's going to get rid of all of the fractions, right? All the denominators.
Oh, wait.
I did that.
So what should I multiply by?
6 times 10 times x minus 2 times x.
You could do that, right?
Oh.
That would get rid of everything. But the way I think about it, and that you'll be fine, right? That'll give you the right
I did
answer.
that, so.
But like I know I'm going to have to multiply by an x and an x minus 2, but you know I also want to think about, well, what's the smallest number that's going to get rid of both 6 and 10? And for me, 30 does that.
Yes. So 30x squared x.
So I'm going to do 30x,
Yes,
so 30x and an x minus 2, 30x and an x minus 2, 30x and an x minus 2.
Forget it. I think I did good, so.
I did that wrong.
All right. Ready?
Do you have to do it
Okay.
like that, or can we do it the other way?
You can do it the other way. All right.
Okay, well, I'm just gonna continue
Okay.
doing it.
All right. So now 6 goes into 35 times, so this gives me 5x times x minus 2. The x minus 2's cancel, so I get a plus 30x. This x cancels, so I get a minus 30 x minus 2. 10 makes that a 3, and so I end up with 9x times x minus 2.
Yay.
And my claim is, I like the way this looks a heck of a lot better than I like the way this looks.
Yes. Indeed.
Right?
Yeah.
Sure.
And so now, you know, I got to multiply some stuff out.
Oh, no, I forgot about the 3.
So
Oh,
I
no,
end up
didn't.
with
Forget it.
5x squared minus 10x plus 30x. When I distribute that, that gives me minus 30x plus 60. Hopefully I have enough room before the screen runs out. Equals, and when I distribute that, that's going to give me 9x squared minus 18x.
Yes.
And I think, yes, it fit in on the screen.
You did?
All right, so what do you do every time you see x squared and x in a number?
Simple.
Well, set equal to 0 and hope it factors, right?
Yeah.
Oh.
Yeah.
Every single time you see x squared and x in a number, you set equal to 0 and hope it factors. I'll clean this up a little bit, so that's going to give me 5x squared minus 10x. The 30x and minus 30x cancel, so I get plus 60. 9x squared minus 18x. Now, I want to set it equal to 0, and I mean I could get a 0 on the right, but I hate factoring if there's a negative in front of the x squared. And so if I subtract 9x squared from both sides, I'll get a negative. So to avoid getting a negative in front of the x squared, I'm going to take all of this stuff and move it over here. And when I take all of this stuff and move it over here, that's going to give me 0 is equal to 4x squared
Plus minus 8x.
Oh, yeah. Minus 8x minus 60. And before I factor, what I'm going to do first,
Quadratic.
Divide by 2.
about 4.
By 4. So, yeah.
They say I can divide everything by 4. At any time you see an equation, like anytime you can divide everything by that number, you want to make the numbers as small as possible. And so if I divide everything by 4,
Oh.
here, I'm going to need to erase this. If I divide everything by 4, that's going to give me 0 is equal to x squared minus 2x minus 15. That's not so bad to factor. X minus 5, x plus 3 equals 0. So what are my answers? 5 and negative 3. But the negative 3 doesn't make a whole lot of sense, does it? Like you can't have negative times. So my answer is 5.
There's got to be a calculator for this.
Is that what you got?
Yeah.
And you're proud of it.
Okay, I
That's
stopped.
the first thing I've gotten right in so long.
No, okay, I did all of it, but like we did it differently because of the beginning thing. But I got all of it. I just subtracted on the other side, and then I got confused with the negatives. I was like, whatever.
Well, now, wait, okay, actually, wait, let's talk about that. Remember I said I don't like having a negative in front of the x
Yeah, I
squared because
know,
it makes
it's
it
a
hard.
little slow.
So you should, I know, but what you've done is you've just figured out for yourself why you don't like having a negative in front of the x squared. So when you're making something equal 0, do it in such a way so that you don't have a negative x squared.
I don't know why, but in my head I didn't know you could do that.
Okay.
So now I
Well, it might be because no one's told you.
Uh-oh.
No, I'm very serious. You're so used to, when you see an equation, you're so used to get a 0 on the right, and that's what you're supposed to do. You don't have to get a 0 on the right. You could get a 0 on the left, particularly if it means you don't have a negative in front.
Awesome. So much
Okay.
fun.
Now,
You do? Okay.
all right, next up.
All the things you do.
I actually don't know.
So, again, this is more practice of how do you translate all the words. So this one starts off, it says, Tim can stuff envelopes 3 times as fast as his daughter. They have to stuff 5,000 envelopes, working together. Tim and his daughter can complete the job in 4 hours. How many hours would it take each of them working alone? Okay. Now we're back to where we were before. Does everybody recognize we got rate of something plus rate of something equals total rate?
Yes.
All right? So if I set this up, it's like, okay, here's rate of Tim plus the rate of his daughter is equal to, I can't say T because I've already taken that, so I'm going to say combined.
Lowercase t.
Are we okay with this?
Equal to what?
Rate of the combined. I can't say rate of total because I'm already using
I
T.
thought
Yeah.
it was an O.
Okay. Now, so what do we know?
The total is 1
Since it took a total of 4 hours, what's going to go over here?
1 over 4.
1 over 4. Is everybody okay with that part?
Yes.
Right? Is that easy to pick out of the problem? Right?
Well, where do you?
And so now let's talk about the rate of Tim and his daughter, right? We know it's going to be 1 over something plus 1 over something, right?
Yes.
Is everybody okay with that?
Yes.
All right? We know it's going to be 1 over something is 1 over something. We've got to figure out what goes here, right? And when it says Tim can stuff envelopes 3 times as fast as his daughter, does it make sense that one of these is going to be X and one of these is going to be 3X?
Yes.
All right? So that's obvious, right? Is everybody okay with that? All right? So we know one of them's X and we know one of them's 3X. Now what may not be obvious is where the X goes and where the 3X goes. All right?
No.
Now,
It is.
before we put those down, the challenge is I want you to think about stuff. And the way I'm going to get you to think about it is I'm going to ask a couple of questions.
Where do you put the 5?
What? Wait, just wait. Right? So I'm gonna wait. I'm gonna ask a couple of questions, right? And you're gonna know the answers,
Yes.
right?
All 4.
If you are faster, do you spend more or less time doing your job?
Less.
Is that obvious?
Yes.
All right? Is everybody okay with that?
Oh,
Yeah.
Okay. All right? Is everybody okay with that?
Yes.
So if you are faster, right, you should spend less time, right?
Should.
We should. All right? Since Tim is faster, is he going to have more or less time?
Well,
Less.
It's better be less, right? Is everybody okay with that? All right, is that obvious?
Yes.
Very, right? Because that's not a hard question, right? We all know how that works.
probably yes.
All right. So if Tim can stuff envelopes, oh shoot, it's not 1. I'll talk about why it's not 1 in a second. Okay.
So obvious.
Okay.
So 1.
So if Tim can stuff as 3 times as fast as his daughter, your tendency might be to say, well, if Tim's going 3 times as fast, so he gets a 3X and his daughter gets an X.
Yes.
But does that mean Tim spent less time?
He spent more time. 3 times that. He's slow.
Do you see why this is wrong?
He's slow.
Do you see the dangers of just reading without thinking?
Yes.
The date.
Yeah. So what should happen is the daughter took longer, so she gets the 3X and he gets the X. And I went through this too fast. I said 1 and 1 and 1. The reason I actually wanted to do this problem is I wanted to talk about their job. Because like the way you set it up is what they did divided by how long it took them to do it, right? And so what did he do?
5,000.
He stuffed 5,000 envelopes. So what he did was 5,000 over X. What did the daughter do?
5,000.
5,000 over X. And the total was
5.
5,000 over X. All right? Yes.
So does it matter which side we put it on though? Like the 3x or the x?
In this case, no. Good question. All right. Now, and the reason is because you're adding, right? So if you're adding, would it matter? Not really, would it? But what if you were subtracting?
Yes.
Then it would matter. I wanted to talk about the difference because one of my jobs when I'm teaching how to do word problems that I teach you how to translate, but it's also easy. I remember being a student, just wanted to do a direct translation and just stick numbers without thinking about them. And what I want to always challenge you to do is sort of think about where things should go and does it make sense. And so that's why I wanted to do this problem. Now, even though I put 5,000 plus and put the 5,000 on top, we could simplify this a lot. Notice, what do you notice is in common with each of these terms? 5,000, right?
Oh.
Since there's a 5,000 with each of these terms, we actually could divide the 5,000 out, so it would be 1 over x plus 1 over 3x equals 1 over 4 and solve that. But I don't want to spend time solving this. Why?
Why is 5,000 overall?
Because that's what you did. It's what you do divided by how long. What did they do? Yes.
So we could just divide it off, then why would you put there?
Okay. Good question. All right, so we make sure everybody understands. The question is, well, if you're going to divide it off, why even put it there in the first place? In this case, it doesn't matter, but in some cases that I'll talk about later, it will. But I wanted to address it now.
Oh, like it's a number?
Well, no, just I said later. I need to get to later. All right. Now, so now let's look at your homework. Yes. We're going to look at those. Oh, there it is. It's like, oh no. And your homework was to set up. Okay. We okay with number 4? Is number 4 very similar to the other problems, the
Yes.
easy problem? I mean, it's almost exactly, right? One copy machine can do it in 30 minutes. The second copy to do it at the same time can be done 8 minutes. How long would the second copy machine do it alone? So you're going to have like 1 over 30 plus 1 over x equals 1 over 18, right? So this is virtually identical to what we've done. And then they tweak it a little bit. So let's look at 5. No. This is easy. I promise. This one's easy. So 2 harvesting machines can each harvest a field in 15 hours. If they are joined by a newer machine, then the 3 machines work together. The job takes 3 hours. How long would it take to do it alone? Okay. So we've got 3 things working, don't we? If I've got 3 things working, it's like, okay, rate of A plus rate of B plus rate of C is equal to rate of the total, right? All right. So what's the rate of the thing that works at 15 hours? What's that going to be? It does one thing in 15, right? So the rate of one of those machines is 1 out of 15, was 1 over 15. What's the rate of the other one?
1 over 15.
1 out of 15. Do I know the rate of the newer machine?
No.
But that's what we're looking for, so that's going to be 1 out of x. Do I know how long it took him to do the whole thing?
No.
Yeah, I do. I think it says it takes 3 hours.
It's okay.
Did that make sense?
Yes.
And if you simplify this, then it ends up being 2 over 15 plus 1 over x is equal to 1 over 3. And that's not that bad to solve. Right? Okay, everybody okay with 5?
Yes.
All right. So now let's look at 6. And the book I got this out of, and the author is, her name's Mary Dolciani, and she's just brilliant as far as how she drives, how she creates problems. Because she creates problems that increase a little bit in difficulty. Because looking at the answer, do you see how this one's just a little bit harder than this? Okay? Not a lot harder, but a little bit, like adds that one more thing. And so now she extends it just a little bit more in question 6. Okay? So in question 6, it says a new model computer is advertised as being 6 hours faster at processing than the older model, right? So we've got a new model and an old model, right? Right? And they tell us that we have 3 of the older models and 2 of the newer models. It's kind of like this thing where we had 2 of the harvesters. Remember we had 2 of the same machine? Right? So if you have 2 of the same machine, if you have 2 of those things working, you get to put 2 over how long it takes each one to do it individually, right? So, we've got old machines and new machines, right? So I'm going to talk about the rate of the old machine and the rate of the new machine, right? Now, as far as the rate of the old machine, how many old machines do we have working?
3.
We got 3. How many new machines do we have working? 2. Okay, we're gonna work together. How long does it take?
1 hour.
1 hour, so that's going to equal 1 over 1, right? And what is x?
How long? Oh, the denominator of the new machine.
Denominator of the new machine, all right? What's here?
6 hours.
6 plus X.
Takes longer,
Yes.
doesn't it?
X plus 6.
X plus 6.
Can you also do like an X and X minus 6?
Yes, but the reason I picked this as x is this is what we're looking for.
Yeah.
They're looking for the times of the new machine. That's why I picked x. But yes, like if you did it that way, when you solve for x, you'd have to remember to subtract 6. Do you see how that's just a little bit more involved than the last one? But do you see how they're closely related? See how can you see sort of the stepping that it does? Just a little bit harder, a little bit harder. All right. So I didn't feel too bad about giving you those 3 problems for homework. But then I said problem 4.
Oh, that was the worst one.
All right.
Oh no, Vici, could you pick up my pencil, please? Oh wait, are you throwing it for me?
And if you looked at problem 4, you might look and say, how on earth does this have anything to do with what I talked about yesterday? Right? Well, it's not. It's the 4th one on the page. It ended up being problem 7. Okay. So if you looked at this, you think, well, how on earth does this have anything to do with what we did, right? Because it doesn't look like it, does it? Does this look like the other problems? No, because the other problems are like, okay, this person does work, we add them together, right? This pipe does work, we add them together, right? What does distance have to do with anything, right? How is that related? Well, do you remember when we came up with, like our formulas? I said the formula, we all started with d equals rate times time,
Yes.
right? And then we said d over t is r. Well, this is actually a distance problem, so we're going to use this. The difference is instead of being interested in rate, I'm interested in time. Okay? And since I'm interested in time, that means time is equal to distance over rate. Does that make sense? Okay? So anytime you're given somebody moving, you are interested in time. Right? And so now what I have, if I look at this, do I have the time of part A and the time of part B equals time of the total? Can we talk about, do we have 2 parts?
Yes.
Do we have the first part and the second part? If we read this problem, it says in a 16-kilometer cross-country ski race, Brett skied the first 7 kilometers at a speed and then increased the speed by 3 kilometers. And in the last, he finished the entire race in 1:20, right?
Yes.
Do we have a first part and a second part?
Yes.
Can we talk about the time of the first part, the time of the second part, and the total time?
Yes.
Right? So let's talk about the time of the first part, the time of the second part, and the total time, right?
Total time is 16 over.
Okay? So the time, right? How we figure out time is distance divided by rate. So time of the first part. What is the distance of the first part?
7.
Does everybody see that the distance is 7?
Yes.
So the distance is 7.
Over X.
Okay? over, I don't know what it is, I'll call it x. Because if you look, that's what we're looking for, isn't it? It says, what is the speed of the first part, right? That's our rate. Okay, let's talk about the time of the second part. What's the distance of the second part?
9.
Everybody okay? The distance of the second part is 9.
Yes.
What's the rate?
X minus X.
Well, his rate increased by 3, right?
Yeah.
Oh, yeah. So what goes here?
X plus 3.
X plus 3. Did they tell us the total time?
Yes. 1 hour and 2 minutes.
They told us the total time was 1 hour and 20. Well, we got to put that in a fraction.
So 4 over 3.
Ends up being 4 over 3.
Or 3 over 2.
No, it's not 1 over. That's our time.
16. Oh, wait.
Isn't this time? Isn't this time? Isn't this time?
Yeah, but wouldn't it be 16
Would it be
over
distance
4
over
over 3?
time? Or distance over,
Yeah.
It's time.
that's right. Yeah.
This is our time. It says the time is 1 hour 20 minutes. And this is, 1 1/3 hour, so that's where I get the 4 over 3.
Yeah.
Now, this looked completely different, didn't it? But does that?
No.
Does that equation look like stuff I've been making you do? Right? And the key to solving this is you think about time. Right? You have to think about time. All right? Here. So I need to talk about this one.
Steel.
Yeah.
Steel.
Because there's two ways, whatever you start talking about time, there's a couple of ways you can look at it. Right? The obvious way is time plus time of the first part plus time of the second part equals total time, right? Because that's kind of what we've been doing. But there's a twist, so I need to make sure I talk about that. So, let's talk about Lucy. Lucy drove 72 miles to a meeting and then returned by the same route. She drove 5 miles an hour slower and 12 minutes longer on the return trip. What was her speed on the way to the meeting? Do we have two trips?
Yes.
We have the first part and the second part, don't we? So let's talk about the first part. Let's talk about time of part A and let's talk about time of part B. And to figure out the time, right, we still have this thing, that distance is equal to, distance equals rate times time, so distance over rate is equal to time. Can we have an expression for the time for part A? What was the distance? Are we okay? The distance is 72?
That's quite a long way.
Okay. So the distance was 72. What was her rate?
Because that's what we're asking.
They didn't tell us, but that's what they wanted to know, isn't it?
They imply it.
Well, no, if you look at it, it says, what was her speed on the way to the meeting, right?
So it'll be X.
So that's going to be X. Let's talk about the second part of the trip. What was the distance?
It was the same.
72.
Oh, yeah. X.
What's her rate?
X minus 5. X plus 5.
Oh, no, she said 5 miles an hour slower, right? And so what goes here? X minus 5. Okay, now, I'd like to say those are equal. All right, I really would. I would like to say that this time and this time are exactly the same. That's what I'd like.
Also,
I want to put an equal sign here. Are they equal?
no.
No.
One to 12 minutes longer.
Plus 12.
Which one's bigger?
Right side.
So let's
Right
go.
side. Right side.
The right side.
Oh,
This,
yeah,
right?
Yeah.
Are we okay that the right side's bigger?
Yes.
So if you think of that equal sign like a seesaw, the big kid's sitting over here, isn't it?
Yes.
Okay? So we need to balance this out, don't we? Now, to balance it out first, it's probably going to have something to do with that 12, isn't it?
Yes.
Right? Because that's time, isn't it? Now, we need hours. We can't deal with minutes. Right? And the reason I have to deal with hours is this is miles per hour and everything else.
1/5 of an hour.
It's 1/5 of an hour. And we get that from 12 over 60, so that ends up being 1/5. So what do I do with the 1/5? Here's our seesaw, right?
You shove it on the.
You either take it away from this side, make this kid lighter, or make this kid heavier, right? So I'll make this kid heavier, so I'll put a plus 1/5. Did that make sense? All right? Good. I got just enough time to talk about this one.
Mr. Roberts?
Yes,
When is the test?
it's on the calendar next Friday.
Oh.
Okay. Okay, thank you.
Okay. All right. Says John Dashwood received 75 cent an hour raise for his part-time job. He can now earn his former weekly salary of $63 working 2 hours less. How many hours a week did he work before he received the raise?
Whoa.
Looks completely different,
I don't
doesn't
know,
it?
let's just ask him.
Yeah, let's just ask it, right? That looks completely different, doesn't it? It does, right? Except, I'm just curious, how many of you have a job?
I wish.
That you're paid hourly?
Yeah.
You got a job that you're paid hourly? So, wait, so I'm going to call it salary because that's the way they call it in this. So, your weekly,
Yeah.
so how you get how do you determine how much money you get is whatever the rate is times however many hours you worked? Is that right?
Yes.
If you're paid hourly, isn't that the money you get? How much you get paid per hour times the rate? Well, doesn't that look an awful lot like our distance equals rate times time?
Oh my God. Wow.
Funny how that silly little formula just keeps showing up, right?
Yeah.
Yeah, it's so fun. It's like
Okay. So, and again, what I'm interested in time. So if your salary is equal to rate times time, that means, are we okay that time is equal to whatever your weekly over R?
Yes.
Does that make sense? So, do we have two different times? Do we have two different situations? We've got the situation before the raise and we've got the situation after the raise. So we're going to talk about time of A and time of B. All right, what do we know? Time of A. What's the salary? What's our salary? What do we get per week? $63. Do we know what the rate is? No. Let's talk about after the raise. How much did you make per week?
63.
63, the same amount, didn't you?
X minus 2.
We got a raise. What's your rate?
X minus 2.
If you get a raise,
X
Oh.
minus 2.
what was your raise? 75 cents. What's going to go here? X plus 0.75. Didn't you get a raise? You had some dollar per hour, right? And someone gave you 75 cents, right?
Yeah, yeah.
And so this is going to be X plus 0.75, isn't it?
Yeah.
Now, I'd like to say these are equal. I'd like to say the time it took to earn $63 is at this rate is going to be the same here, isn't it? Are they equal? No. Which one's bigger, the left or the right?
Right.
Right.
Oh my gosh, I'm an idiot.
He worked more hours here, didn't he?
Yes.
Okay? So the left from your perspective, not mine, right? Does everybody see now the seesaw's this way, the big kid sitting over here? Now, do we know how to balance this out? Because we're talking about time, aren't we? Because this is a time and this is a time. What do I need to do to balance it out?
Balance.
Add 2 hours of this side.